Good morning, children. Here we are again. Physics, class 8, light. We are continuing with the chapter. Okay. So I think the last time I did rules of refraction, Snell's law, laws of refraction. Okay, all those things are very important. Rules of refraction are very important. You need to understand this right now. Okay. Now what we're going to do is refraction of light through a parallel side glass slab. If you look at page number 71, there is an activity. I will not be doing the activity in detail because there's something we'll have to do in terms of practical in class 9 and 10. I'm not very sure. By 10 you'll be doing it. Okay? But I'm just going to show you, introduce you to the few things that are there out here, what you need to know, and new terms that you need to come across. Okay? There's not only a refraction, there's more terms, and how it behaves, I'm going to explain that to you. So we have a glass slab, materials required a parallel-sided glass slab, okay, and you draw this on a piece of paper. Then you make this incident ray, okay, incident ray, and in IR, okay. Then you make a normal. This is the normal. This is normal one. This is normal two. Okay. Then the light gets refracted. This is the refracted ray. Then again it will come out as emergent ray. So what are the angles that are formed? Angle of incidence, angle of refraction, angle of emergence. Okay. So these are the most important things, and I'll be talking to you about lateral displacement also. But I'm just trying to explain this to you. So when you're doing this practical later in the high classes, you'll have to make this line, you have to make a normal, you put two pins, you have to see from this side and put the pins and try to put them in a straight line, and when you circle the pin holes and draw a line, make a normal, and when you make this refracted ray, you realize that there is a deviation. Why does this deviation happen? To compensate for the loss in speed, the light ray bends. Okay, that is the whole concept of refraction. Right? So, the more important term as this 2D object is incident ray, refracted ray, and emergent ray. Okay. Angle of emergence is small, angle of refraction is small, angle of incidence is small. Two normals. Okay. Now this lateral displacement as I go observation, I'll explain it to you. So the observation states that the incident ray, the normal, and the refracted ray all are drawn on the same sheet of paper or lie on the same plane. Hence, the first law of refraction is very true. I told you, you take a glass slab, you put it on a paper, make an outline, then you draw lines. If you see, everything is being done on a sheet of paper. So, laws of refraction, if you go to page number 69, the first law says, the incident ray, the normal at the point of incidence, the normal at the point is the point of incidence, okay, and the refracted ray all lie on the same plane. So, law number 1 is put it. Now, number 2, the ratio sin I upon sin R. Sine of incidence upon sine of refraction. Again, you haven't done trigonometry, we'll be doing this later on in the high classes, but still this is a constant which is given by the symbol mu. Mu looks like y, but not exactly a y also. Okay. So it says the ratio sin I upon sin R is found to be constant for two given media. That means two given media. Mediums is air and water, water and kerosene, air and kerosene. These are different mediums. Glass and air, water and air, one medium to. So when a light passes from one medium to another medium, the refractive index. Okay, after this we come, constant is nothing but if you go back, I've already told you this. It's called the refractive index. Okay. If you go back to page number 70, it says the value of the constant is fixed for a set of two transparent media and depends upon the nature. It is called refractive index of the second medium with respect to the first and is represented by the Greek letter mu. Refractive index is a ratio of two similar quantities, thus it has no units. Okay. So this thing out here says that the ratio of sin I upon sin R is found to be constant for two given media, that is glass and air. Hence Snell's law is verified. Okay. So it will never change. Constant that I'm talking about move is nothing but refractive index. If you go to page number 70 again, if you look at the table 5.4, you can see the various materials and the refractive index like air, water. Okay, this is how we calculate. Last time I showed you how we calculate also. Okay, there are calculations, but again, sign and all those things involved which you will not understand, so I will not be able to do the sums. But just remember this one. Okay. The third point. The angle of incidence and the angle of emergence are always equal. These two angles. So angle of incidence is always equal to angle of emergence. Understood? Emergence means emergent ray. After deviation, after refraction, that comes out. Okay. Now it says the angle of incidence and the angle of emergence are always equal. In other words, the emergent ray is always parallel to the incident. Emergent ray is always parallel to the incident ray. See, if the incident ray did not deviate or it did not refract or it did not bend, how would it have gone like this? See, right? So, if you look at the emergent ray, this is a freehand drawing, children. I haven't used any scales. I'm trying to just show, explain it to you. These two, incident ray, had it not got deviated and gone straight to the glass slab, this would have been the part. But it deviates and comes up, and this is the new part, but they are always parallel to each other. Okay. So the emergent ray is and the incident ray are always parallel to each other. The emergent ray shifts from the path of the incident ray. Emergent ray shifts from the path of the incident ray. Thus, when a ray of light passes through a rectangular glass slab, it emerges parallel to the incident ray and is shifted from its original path. This is the original path, but it's shifted. This is the new path. Okay. The perpendicular distance between the emergent ray and the incident ray is called lateral displacement. This is what I'm talking about. That's why written D. D is lateral displacement. Okay, so this is the way it is. Okay, so important term is reflection of light through a parallel sided glass slab is incident ray, refracted ray, new term, emergent ray. Okay, angle of incidence, angle of refraction, emergent angle, angle of emergence, new term again. Now, what is lateral displacement? If the incident ray had not deviated and had gone straight to the glass slab without any deviation, this would have been the original path, but it deviates, and the new path is this. So they will travel parallel to each other. The perpendicular distance, this is also 90 degrees, like this. The perpendicular distance between the incident ray and emergent ray is called lateral displacement. Okay? So these are the important things that you need to know from this. Now we move on from this. Now we move to prism. Prism also, there is an activity given. You have to do that in class 9 or 10. I'm not very sure when. Okay, so topic first. Now, prism, I wish I could get a prism right now, but not possible right now. Okay, it's a glass block that has a triangular cross section. It's a triangular piece of block of glass that looks like a pyramid, formed by three rectangular faces. The rectangular faces are refracting surfaces, and the angle made by the two, this is called angle. Okay, we will not come to that first. Just let me make the diagram, and I'll explain all to you. Page number 72, figure 5.25. I'm just trying to replicate that. You can go through that also. So this is Now, this is the incident ray. In the book, it's given as XY. I'm not going to name it. This is the incident ray, and this is the refracted ray, and this is the emergent ray. Okay, so this is the incident ray, refracted ray, and emergent ray. These three rays. Okay. I is the angle of incidence. R1 is the angle of refraction in the first case, and R2 is the angle of incidence of the second. Okay, now this is the angle of incidence. It's incident ray now. Refraction. But this is one plane of separation, right? So this will be first incidence. Though this ray is a refracted ray, but when it goes and meets this glass slab, it becomes an incident ray. R2. It should be I2, but in the book it's given as R2, so we will call it R2. Okay. So R2 is the angle of incidence in the second phase, and E is the angle of emergence. Angle D is the angle of deviation. Angle A is the angle of prism. What is the angle of deviation? Again, activity 2 is given. I'm not going to go through the activity. I'm just going to tell you this is a few things that you need to know out here is what is the angle of deviation? It is the angle through which the incident ray is deviated by the prism. Through which the incident ray is deviated by. So out here, so what you need to do is you take a plain sheet of paper, you put the prism. Okay. You need to draw the outline. Okay, then again you put two pins out here, then you have to see from this side, you have to see, put the pins in a straight line, then you have to draw all these rays. Okay, so what is the observation that you have out here is, observation says that angle of incidence plus angle of emergence is always equal to angle of collision plus angle of deviation. That is equal. Angle of incidence plus angle of emergence is always equal to angle of result plus angle of deviation. When you add these two, the value should be equal to the addition of the value of these two. Understood? In the previous one, we always saw the angle of incidence, rectangular glass slab was equal to angle of emission. Okay. So this is all you need to know about this. Okay. Now, why are we doing prism? Because there is another topic out here which is important for us, class 8. It is called dispersion of white light by a prism. Okay. So, in 1666, Sir Isaac Newton, he observed a phenomena where white light, when it was incident on a prism, when white light was incident on a prism, when white light was incident on a prism, a beam of light is incident on it, gets split into constituent colors. That means there are 7 colors. Okay, the colors of the rainbow. Okay, so it was Sir Isaac Newton in 1666 he discovered this. He found that white light consists of 7 colors and it splits into its 7 components when allowed to pass through a prism. Okay, so what is the order? It will be 7 colors: violet, indigo, blue, green, yellow, orange, and this order. These are the 7 colors of the rainbow. Okay. What happens out here is, when a white light, a bundle of light, when it passes through a prism, it splits into 7 colors. Okay. The colors are in order: violet, indigo, blue, green, yellow, orange, red. And this is what we see when you have to see a rainbow, and this whole phenomena in physics is called spectrum. This whole thing is called the spectrum. Again, I think in first time you have to do a practical concerning color disk and all these things. Okay, so you understand this more clearly. So the band of 7 colors is called spectrum, And why does the dispersion occur? It's given in the book. Dispersion of light occurs because the refractive index of a medium with respect to another medium is different for different colors. Understood? That is why deviation occurs. That's why this white light is not coming as one light, it's coming as 7 lights. Okay. Now, the red color deviates or bends the least. See, red it deviates or bends the least. Okay. Whereas violet deviates the most. That is why red is easily visible. We can see it from very far away. That's why VIPs, their cars are made of red light. Ambulance, if it's written on a car, is usually written in red. This is you see a little bit of blue also. But blue again you can see is third from bottom. Okay. So red, the color red is always danger, important, everything is signified to make note that color red. This is the reason why. It deviates the list and it is highly visible from great distances also. Okay. So this is why red forms the top band and spectrum of violet forms the bottom band. Okay. So if two prisms are placed next to each other, adjacent faces, okay, you take one prism like this, you take another prism like this white light will come, 7 colors will come out here. Now again, this will, okay, if you go to page number 74, with the 5.28, this color it will come as a band white light, deviates into the 7 colors of the pure spectrum, then again all of them multiple of them come out as a single white beam of light. Okay, therefore two prisms kept opposite to each other behaves like a glass slab. We put them together, it behaves like a glass slab. Key point in the book says dispersion occurs mainly because the different components of light bend differently and move with different speeds through the material of the prism. Okay, so bending is all about speed, as I told you. Refraction. Refraction is all about compensation in the speed, loss of speed, due to which the angle of deviation, the angle at which it refracts, which deviates is always there. Okay, now, so the natural phenomena that we see, the effect of dispersion that we see is the rainbow. It is a fascinating example. There are stories of rainbows, like they say if you can trace the end of a rainbow, you'll find a pot of gold. The pot of gold has been hidden by leprechauns. Leprechauns are mythological figures of fairy tales who are greedy little people from Ireland. Okay, they wear long green hats and they wear green coats and they wear boots and beard and all those things are there. And they're very greedy, stingy, greedy. They keep hiding gold. So leprechauns hide the gold at the end of the rainbow. But the sad fact is, you will never see the start of a rainbow. You will never see the end of the rainbow. Because how does a rainbow form? A rainbow is formed soon after a light drizzle. We tend to see a rainbow. You don't see a rainbow on a dry day, on a moistureless day. If there's a lot of moisture in the air and the light from the sun is getting refracted through the droplets of water with access prisms, that's when you see the rainbow. Understood? So there is no end or a start to a rainbow as such in this sea case phenomenon. So this is the natural phenomena that we see the effect of dispersion, which is very important to understand. Okay, so with that we come to the end of the chapter. You need to go through it properly. Ma'am has already given you the notes. Go through it. If you do not understand anything, please let me know. Thank you, children.